To begin with, first and foremost, we should know what exactly is an identity matrix. An identity matrix of order 2 or order 3 will have the diagonal elements to be equal to 1. All the other elements will be equal to 0. So identity matrix need to be a square matrix and the diagonal elements should be equal to 1. Further, here in this case, identity matrix is being identified as letter I. If there is a matrix A multiplied by I or I multiplied by A, the answer will be equal to A itself. That is A into I or I multiplied by A will be equal to A itself. The inverse of the matrix. So whenever a matrix is multiplied with another matrix and the result value is identity matrix, then this matrix would be a inverse matrix, which means that A times A inverse or A inverse times A is equal to I. Keep in mind, it is the only in this case that pre-multiple or post-multiple, the answer is same. So A into A inverse or A inverse into A will be equal to I. If you are given a matrix A having elements A, B, C, D, then the inverse matrix can be found out by taking the determinant's value. The determinant value of A is A times D minus B times C. So the determinant value is equal to A times D minus B times C is the determinant value, which will be a number from a given matrix. Multiplied by, you have to swap D to A and A to D. So you swap D and A and change the signs of B and C. Once again, to find out the value of A inverse, you first need to find the determinant value of A. The determinant value of A will be equal to A times D minus B times C multiplied by the matrix A, which is basically the swapping of A and D. So D and A are both swapped over here, and this diagonal, the signs have changed from positive to negative. Also to be understood over here that the determinant value should not be equal to 0. Only then the value of A inverse can be determined. So inverse matrix does not exist if the determinant value will become equal to 0. Now we see how to solve simultaneous linear equation using the matrix method. You have two simultaneous equations, ax plus by is equal to p and cx plus dy is equal to q. This simultaneous equation can be written in the form of a matrix. The coefficients a, b, c, d will form the first matrix. X and y will become the column matrix, and this p and q will be equal to the matrix B in this case. So the transformation of the simultaneous equation will be done in terms of the matrix form Ax is equal to B. Further to that, since Ax is equal to B, you pre-multiply both the sides with A inverse. You are pre-multiplying, so you have to pre-multiply with B itself. So A inverse into A is I, and A inverse remains here itself. So value of X will become equal to A inverse times B. Your work is now to find A inverse. A inverse will be equal to find the determinant value of the matrix A, which is over here, swap A and D and change the signs of B and C. First take the determinant value, then divide it, well, the determinant value for each and every element and multiply with P and Q. That will be the value of X and Y. This can be illustrated with an example. Here is an example given. A building has several parking spaces for cars and motorcycles. On a day, there are total 66 vehicles parked and there are total number of wheels are 190. So the observer has observed that there are 16 vehicles totally and 190 wheels are there. Calculate the number of cars and the number of motorcycle parked that day using the matrix method. We have to assume that all motorcycles are two-wheelers. Cars are definitely four-wheelers. Now let us assume that the number of cars be equal to X and number of motorcycle be equal to Y. Since there are total 66 vehicles are there, we can say X plus Y will be equal to 66. So we get X plus Y is equal to 66 because there are total 66 vehicles are there. And there are four-wheelers as well as two-wheelers. So four-wheelers car multi plus the two-wheelers, the motorcycles, the total number of wheels is 190. Four-wheelers, that is cars, X plus two-wheelers, that is motorcycle, will be equal to 190. So these are the two equations, which simultaneous equations you have formed. The simultaneous equation can be written in the matrix form. The first thing you have to write in matrix, 4, 1, 2, 1 are the coefficients of X and Y. X and Y will be the multiplication matrix. This equation now can be written in the form of AX is equal to B. Therefore, X will become equal to A inverse times B. Therefore, X will become equal to A inverse. A inverse is to find the determinant value. This is our matrix. 4 times 1 is 4. 2 times 1 is 2. 4 minus 2 is equal to 2. We have swapped this. 4 comes over here. 1 comes over here. And the sign has changed. Divide this matrix everywhere by 2. You will get 1 by 2 minus 1 minus 1 by 2 and 2, which is shown in the next equation. So after dividing each element of 2, you are getting this value. Now multiply this matrix with the matrix 190 and 66. After multiplication, you will get number of cars will be 29 and number of motorcycles will be 37.